Welcome to part 3 of Let's Build a Quant Trading Strategy. In this video, we're going to be focusing on the implementation. In the previous videos, we looked at part 1, which was the research, which was to build a model that takes an input and it makes a prediction. And then in the second part, we looked at using that prediction, putting it into a strategy, and then that strategy generates orders. And then the orders are then executed onto an exchange. So we've already covered this, but I'm going to do a recap just in case that you haven't watched part 1 or part 2, that you can easily follow this independently. So the key goals for this is to code it all together in Python. So essentially, it's like cooking. We've got the ingredients. We've got the recipe. Now we just need to put it all together. So we're going to see how to gel the model and the strategy together and how to stream data into it. So ideally, it would be better to do it in a statically typed language like Rust, but we're just going to use Python because this is the most basic language just to code with. And also because all of our research so far has all been done in Python. And then the other goal is to show how to build a trading system in a scalable way so that it's like you can easily create new strategies. So we'll look at like building a strategy API and also how to stream the data. So we're not going to look purely on like just on the high performance side because that could be a video separately by itself. But yeah, we're going to put it live with real money to see how it performs. So that'll be the next video probably. We'll connect it to an exchange. We'll use some real money, just a small amount, and we'll see how it goes. And even if, for example, the performance starts to decay, which is called like model drift or alpha decay, then we can learn from this and we can see like, okay, what do you do if your model stops? The pattern it's learned is not persistence anymore. So yeah. Even if we put it live and the performance starts to decay, we can have a look to see why it happened and the solutions to it. So now let's go into a recap. So let's write this down here. So now we're going to do a recap. So in part 1, we looked at the research part. And in the research, we built a model. We iterated and built a model. And in the model, so I'm just going to, oops. So we've got our models and we've stored them in this file called models.py. And then we're going to import our machine learning library, Torch, and we're going to import the research API. And the research API is just an internal API that I've built just to remove a lot of the boilerplate pertaining to research. And then we're going to instantiate the model, because I just want to show you the model that we built. And so there was 3 features to the model, and then we're just going to load the parameters from disk. And so we do torch.load models, and it should pick it up. Yeah. And we also, it's very important to pick this weights only equals true, because this just ensures that it doesn't run any arbitrary code that could be could be quite dangerous to run some arbitrary code. So it's very important that you pass this as true. And then we're going to put it in evaluation mode. So this makes sure that any layers that are just strictly pertaining to training is not run. So for example, like here it says here like dropout. So it won't run this. But because ours is a linear model, that we don't have any of this. But it's just when we, like for example, if we go to neural networks, then yeah, we want to make sure. So it's just very good practice. And so now we're just going to run this. And you can see here, there's input is 3 and the output is 1, and you've got a bias. So this is a linear model. And specifically, what we built is what's called in econometric is an autoregressive 3 model. And that was to predict, and so it's to predict the future log return with a 12-hour forecast horizon. Okay, so, and I'm just going to show what the parameters of this model. So now we do research, print model parameters, and we're going to print the model, and we're going to see the parameters. And the beauty of linear models is that they have great interpretability. So, for example, we can see that the first 2 lags, the most recent lags, have a negative coefficient or negative weight. So this can imply a mean reversion, a weak mean reversion pattern here. So this is essentially what this model is modeling, is a mean reversion. And now, so that's the recap of the first video. So I've just saved you like 2 hours there. And to save you another 2 hours, I will now just recap on part 2. Oops. And so with part 2, we're looking at the strategy. And we made like, there's 2 key decisions there. And I'm just going to go over them. Okay, so the first part was like, for example, we just, without any optimizations, it came to like 14% was the original, like, so I'm just going to put this here. It was roughly around about I think it's 14.4%, and without any optimization. And then we looked at like 2 key decisions that essentially were optimizing the strategy. So, for example, we used what was called, the first key decision was compounding trade sizing. And essentially what this was doing was using all, like for example, if our trade made, let's say we started with $100 and it made $5, so then the next trade would open a position with $105. So it was just reinvesting the money for the next position. So, and this was because you're essentially compounding. So this is the first key decision. And then the second one was that we used leverage. And that's essentially where you're borrowing money. So this can amplify your profits, but it could also amplify your losses. So it's very important that you use this with an edge. And then by using these 2, it turned the returns from 14% to over 40%. I can't remember how much roughly it was, but it was like over 40%. And the reason for this was because of the leverage, the compound trade sizing, and the model's edge. So all those 3 together produce these like a phenomenal increase in the returns. So that's the strategy recap. So I think we're all ready to start on part 3. And so I've saved you over 4 hours there. So now we're going to go over the fundamental building block, which is this. I'm just going to maybe fundamental building block. Just like building a house, there has to be like a foundation. So our foundation is what's called what I call is a tick. And the tick is, I'm actually just, rather than, because it's not, I'm just going to copy and paste it to save time. Explain it. Okay, so this is an abstract class, so it doesn't have any implementation. I expect whatever extends this class is to implement this method. And it's essentially like, how do you handle new data coming from the exchange? So this could be like order book data coming in. This could be a trade feed. It could be just, I don't know, just a generic open, high, low, close pricing time series. It's just like when there's a new information or new data, what should it do? And it's like how you, like event handling essentially. But don't worry if this doesn't make sense. And also, this is important that it's generic, so it has this thing called polymorphism. So rather than hard code it to specific types that it's, and like for example having a tick, I don't know, float tick or a string tick or a decimal tick, that it's completely generic, so you don't need like to code up specific implementations. But don't worry if this doesn't make sense, because hopefully later on this should make sense. So that's our essential building block, is this tick class. And then the fundamental data structure is the sliding window. And the sliding window essentially memorizes the most recent data points. So if imagine like your millions of trades were coming in, and you just may be only interested in like the most recent ones. You don't want to store like, let's say you've got 10 million in a day or 10 million. You're just interested in like the last, I don't know, the last known 20. So it's a bit like, Netflix, how they stream movies. They don't just get you to download like 10 gigabyte movies straight away. They stream it as you watch it in. So they just download the data just in time for you to watch it. And it's exactly the same here. We're just streaming the data in just in time to make decisions. So now this is the fundamental data structure. I'm going to put this in Markdown. And rather than me just code it, I'm going to just copy and paste it to save some time. Okay. So essentially the data structure behind it is what's called a double-ended queue. This allows you to insert at the front and at the back in what's called constant time. It's like, for example, if you ever heard of big O notation. So it's basically, it scales like constantly regardless of the size of the data. So it's just allows it to be more efficient than using an array. We don't need to get bogged down into the details, but I recommend to have a look and see how it's actually implement. I also feel to get better at coding, you should try and implement some of these like fundamental data structures, because that really helps you to give you a better understanding of the underlying data structures. So essentially, the key important thing is that it's called a Deque window, because it's using a Deque, and it's still generic because we're just saying that the input is T, and we're saying that the output is an optional of T. So this optional essentially is saying that it's either going to be of T or it's going to be none. So for example, if you've used Rust, this is equivalent, or Haskell, this is equivalent of option. So, but it doesn't have the algebraic data types. But anyway, this is, so you've got dropped, and yeah, so when it's full, we drop the data point at point 0, and then we append the new data point into it, and then we return the drop just in case whoever the client is calling this, that it can handle if it wants to know what was dropped. And then this is just boilerplate code. And just another important part is that we can also append, so it'll append it to the right, but you can also append to the left, so that's the front of the queue. And that's quite important to us later on, but we don't need to know for now. And then, yeah, for example, we want to convert it into a NumPy, but we'll explain that later. So that's the core of this Deque window. But it would make more sense if we actually just run a few examples. So here are a few examples. So let's just say we create a window of 3. So it has a capacity of 3 and is empty. And now what we're going to do is to create, like, just for example again, but we're just going to do on tick. So let's say a data point comes in, and just see what happens. So you see here, it stores as 1. Okay, but now let's see what happens when we, let's say, let's again still Deque window, and this time we're going to call on tick 1, 2, and then 3. Oh, and then we're going to print W. So you see here, it stores it, so that's just behaves like like an array would, right? But now let's just say that we're just now going to append 4 to it. So you see here, 1 has now been dropped, and if we wanted to keep 1, then we would store this as a local variable from here, and you can see now it's still capacity is 3, but the 1's removed, and we've now just appended 4, and it's at the end. So that's essentially how it works. It's called a sliding window. And yeah, so now what we can do is, I just want to show you just another example, which is like, for example, let's do this. So as you can see, it's just like, it's like a memory. It just only memorizes the last known values, and we're saying like we want to memorize. So you can see here like what it's doing, and so now what I want to do is to show. So that was a Deque, and you may be guessing, well, we can just use like a normal array-based window, and I just want to, because what we'll do is we'll implement it, and then we're going to do a performance benchmark and see which one is faster. So for the array-based window, I'm just going to, rather than, so I think it'd be very boring if I just code this, is I just take this code. It's pretty much the same, apart from that we manually are shifting the values in the array, but it's pretty much the same. And rather than just, so now what we're going to do is we're going to benchmark the NumPy window, or the array window, versus the Deque window. And what I'll do is I'll just maybe just copy and paste this code. So that's the functionality to do the benchmarking. So now what we're going to do is we're going to benchmark. And I also want you to maybe, let's look at the results and see which one is fastest. And I would love you to write in the comments why you believe the other is faster, that one is faster than the other. So first we're going to do that for the array-based window. Pardon me. And then we're going to do it with the Deque window. So that took 5 seconds. So now let's say if Deque is going to be faster. So let me just show the implementation as well. So NumPy is an array, so it's a contiguous memory allocation, whereas Deque is a linked list, which is non-contiguous. So it allocates memory different, has memory, so it's not all in one line. It's not inlined memory slot. So now let's run this. So you see here, it's much faster to use the Deque. And maybe if you put in the comments why you believe this, it is. I think I've already given some hints anyway but yeah. So, and another important thing is to stream like the last known value. The last known value. So for example, we want to track for each time interval, we want to track the last known trading price. And to do this, we need to aggregate the last known value. and it's quite easy to code up. One I'll do again is I'll just copy and paste our code. So this is essentially it. So I don't think we need this generic T, but I think sometimes the linter complains. So we have this. The most important thing is that we're extending tick, and to extend tick, we also must implement on tick method. So essentially, what it's doing is we're storing this optional of T, we're setting it to none, and then once a tick comes in, we just update it and also return it as well. That's not true, and that's that. And I just want to just show some examples of this now. So last val last, the constructor is empty, and we're just going to print it out. So it sets it to none, and let's just do this. We'll just iterate, just let's say 5 times. Maybe so you see here the last known value is 4. It starts from 0. So again, it's quite trivial, but it's just important to be able to stream the last known trading price. So now what we want to do though is to stream log returns. So we need to build prices to build the log returns, and then we'll take the last 3 known log returns and pass that into our model. So we're going to do streaming. Oops, I keep on pressing that. Streaming log returns. And just I need to give like a recap first of this. So we'll just quickly do a quick recap of what log returns are. So log returns, so let's start with an example would be best way. Okay, so for example, if like just use the same example that I used in the previous videos. So for example, if we have a time series, a price time series, and it starts at 100, goes up to 120, and then drops back down to 100. If we calculate the log returns for this, then it's essentially this. It's log time series 1 over time series at 0.0. Then we're interested in the second index. So that will calculate the log returns of this price time series, and we also want to print it out. So you see here, so the beauty of log returns is that they're symmetric, that you can add them up, and that gives you your net return position. So if we add this up, then it's exactly the same. Like for example, if we took the deltas, the price difference between them, and add them up, then you would get to 100. And so exactly the same with log returns. If you add them together, you get the total. So for example, just to make it very clear, if I do the sum of log returns, and this is the property is called time additivity. So then we add them up, we get to 0. And so now you have an understanding of log returns. So now let's stream log returns. So we need to, from the, yeah, actually maybe if it's easier if I show you. So we take the log return. This is essentially streaming log returns. So we're using, this is an important detail, is that we're going to, even though it's just a window size of 2, but it's just easier because we can access so we want to access it like this. It just makes it easier to access the elements. So essentially what it's doing is that once it's full, as in we've got 2 prices to calculate log return, we calculate the log return. but we always like update it, so we drop like the oldest value. So that's how the log returns are calculated. But just to make it more concrete, let's show an example. So what we're going to do is our streaming function is this log return. We're going to call onTick 100, and we're just going to print out to see what it looks like under the hood. So you can see here we've got a capacity of 2, the size is 1, and you can see in the array we just have one element, 100. So far so good. And now what we're going to do is we're going to say 120, and we're going to print the value out. So you see here it's now generated the log return. So from 120 from 100 to 120, you can see it moved up by $20, and that's roughly 18.2 in log space. And now if we look at the under the hood, you can see, okay, that it's calculated from this array here. So now if I want to now calculate the other way now, so for example, let's just call f onTick. So in our price we went back down to 100, and we're going to print out the value. So it should just be the negative of this, and you can see this here that it's now it's 18. So, and then if we have a look and see what's going on under the hood again, you can see that the oldest value has been dropped, and now that value has moved over to this side, and then the 100, which is the most recent price, is at the end. So this is how it streams log returns. So it's not like an array of 1 million prices and then just take like the last 2. It just streams it intelligently, so that the memory is always of a constant size. So that's log returns, but we actually want to pass into our stream what's called, maybe if I put this down. So what we want to do is to stream what's called auto-regressive log returns, lags. So the lags are essentially the previous values in the time series, and I'll also do just a quick recap as well, what they are. So the recap, if I just put a recap here, because I appreciate not everyone has watched part 1 and part 2, but just maybe interested in just the coding side. So for example, let's say we have a time series, and let's say it's just log returns, and I don't know, so minus 0.2, and then the most recent is always on the right, and then the oldest on the left. Okay, so for example, if I call, if you hear me say lag 1, what essentially what I'm saying is the most recent. Let's say this is the current values, and we want to predict in the future. We don't know what that value is. So this is lag 1. So I'm just going to make that explicit here. So when you take a negative index, you're flipping it to say, okay, the first element from the back. So for now, you can see it's -3. Okay, and then for lag 2, it's just time series -2. And then 0, 1. Okay, so that's lags. So if you hear me say like lags or auto-regression, then you can understand what this is. So now we're going to look at the coding of it though. And so to do this, I think it'll be quicker if I just copy and paste the code and go over it. And again, we're just extending the tick class because we want to implement on tick, and the key in the constructor, the key thing is the number of lags that we're interested in. So we're saying here that we're interested in an arbitrary amount, and then that's where we create the Deque window, and then we've got the log return aggregator. So this streams the log, as you've seen it before, but it streams the prices and generates log returns once the window's filled up. And then we just generate call log return on tick. This will either be none or it will actually have a log return. So this is what we check for. And if there is a log return, then we append it to the lags, our Deque window. And then when it's, we append it to the left, and so this is a key. So we generate a torch tensor. Because our model is in PyTorch and it works with tensors, not arrays, or NumPy arrays. But what we do though, this is a key important detail, is that we pass in a NumPy array. And the reason for this, and not just say like a Python list, is with NumPy, it can do what like a zero memory copy. So you can allocate the memory as a NumPy array and then pass into tensor, and it doesn't create a copy of it. It just does like a memory swap essentially. So it's like what's called like a zero copy. So that's essentially why I implemented this into NumPy. And then we only do this if the lags is full, else we just return none. But don't worry if you don't understand what this is doing, because we'll just use some examples to build the intuition. So what I'll do is I will So you see here on the first tick, it's say $90. We add it to the log return window, but it doesn't generate a log return because the window is not at full capacity yet. So now let's just well, let me just, easier if I just copy and paste again. So now we're going to run it again. And you can see now that it's generated a log return, because it's now got two numbers to do it, and it's now added it in our Deque window, but it hasn't returned, this hasn't returned anything because it needs, it's not at full capacity yet. So we haven't got enough features yet. So this, just to make it clear, so this is the features that's passed into our model. So, and now what we're going to do is just to keep running this until the window is full, and we actually can pass it to the model. And we're just going to do it explicitly here, but when we build our strategy, this is what strategy is going to be doing. So if I now run this now, you can see now we've got two. So on the next one, it's going to generate the tensor. So, and we can see this here. So if we run, and these are log returns, by the way. So, and it's already got into a tensor, so we can pass this into our model. And just to show what it's doing, so maybe if I just show you the math behind it. So this is the equivalent of this. Or maybe just remove that. So that's essentially what it's calculated, but it's doing it while streaming pricing data in. So just maybe show another example, just all together. So if we're going to create the features, let's just run this. And now I just want to show like streaming now we're going to do the stream features into our model. So we've called these features. We can call them X, which we'll probably do just to make it more explicit. So we've got the features, and remember from the previous lessons that when we don't want to we want to run it in no gradient, so that disables gradient calculations because we don't need it for inference. So then y hat equals model of x and then it's made a prediction. So it's made a prediction here that it's going to go down, and just from a superficial look, we can see that's because our biggest weight is at lag 1. So this strongly influences this lag 1 strongly influences the inference. So now it's made the prediction, but this is comes as a one-dimensional array, and we want to get it as a scalar. The scalar is essentially just like a single value. So we can then just do y hat 0. So now we've got it, but it's still a tensor, but we can convert this back, we can detach it. Maybe it's on the GPU or on the CPU, and we detach it and we can put it back into to be used. And now that's the streaming functionality of our trading system. And so now we're going to go focus on the architecture and actually building the system. So we're going to do build the trading system. So I just wanted to show you the streaming functionality of the system. And another really key important lesson is the using decimal to represent money. So I'll make it as a headline as well. Using decimal to represent money. And to build the intuition to explain why, it'd be better if I show an example. So maybe if I just copy and paste this code again. So essentially, let's just say like we're in a loop and we're adding up. Let's say we make 10 cents every time and we want to add it up. So it should add up to 1.0, but if we run it, it doesn't. And we need this accuracy to represent money, because like imagine like having small errors like this and they compound, and then the calculations become way off. It's like a butterfly effect. So the way we can get around this is by using decimal. And so now if we do exactly the same, you can see now it's 1.0. So it represents the accuracy correctly, and it's using something called like fixed point precision. So it's important to understand this. So now we need to create some like data classes. So the first one we need to do is, and I'm going to copy and paste because it's quite trivial. Is our order. And then the next one we need to do, so this represents an order that we send to the exchange. An important detail is obviously the symbol, which is what we want to buy or sell. But we're going to encode the direction and the quantity of the order in one variable. So if it's negative, then we're saying we want to go short. And if it's positive, we want to go long. So it just saves having another variable saying is long or is short. Then I just like to encode it into one. So that's our class. And now what we want to do is to create a trade class. And again, we're just going to copy and paste. So it's quite, there isn't in the decimal class, there isn't a method to get the sign, essentially, if it's 1 if it's positive or -1 if it's negative. So I've just written some functionality to do that. And then, so it's just pretty much the same as the order, but we have a price that it traded at and the P&L. So, for example, if this was to open a trade, then there's no associated profit with that trade, because it's just opening a position or increasing the position size. But when we start to close or reduce the position, there's an associated profit or loss with the trade. So it could either be none or zero, sorry, or it could actually have a value associated with it. So that's the trade class. And now what we want to do is create a position class. And with the position class, and again, it's just it's the same. And this is just a very basic representation because, for example, it could be you need to monitor the average price. For example, you don't always the position could be traded at different. You could have trades at multiple different prices and sizes, and you need to calculate like an average position price. Another important is this method called unrealized P&L. So this is also called mark to market. So it's like saying, if we close our position, how much profit would we make if we close it right now? And if we do close it, it's called like a realized P&L because we've actually realized that a profit or a loss. So we just call this unrealized, but this is also, you might hear this be called mark to market. And then to calculate it, we just have calculate the notional value at entry and the notional value at exit. And yeah, then that's our unrealized P&L. And we're just going to run this. So that's the data classes. And now what we need to do is to create a base class for account management. So when you have an account, you need to know what the balance is and you'll be able to get like positions. So and this is just there's a lot more methods that you would need, but I'm just adding the most basic just to show as an example, as a base. So yeah. So that's, and again, it's an abstract method. If we extend this class, for example, we can have accounts for different, let's say, Binance, all different exchanges, and even just, let's say, brokers, for example, Awanda, I don't know other ones, but yeah, so and interactive brokers. So this is like our base class to extend from. And what we're going to do is just create a test dummy account just as a mock. So to do this, we're going to do this. So maybe I'll just go over the details here. Don't need this. So we have a balance. We have positions, which is the direction our trades are in. And then this is the individual trades. So we can see the trades that are opening and the trades that are closing. And then we have this, actually we don't need this counter. And then we implement the balance and implement this get position. And here's a key important thing. So for example, if we use the index access, which, you know, the brackets, and it's not there, then it throws an exception. So I'm going to use this get, because then if it's not found, then it just returns none. And this complements, because our return type is like optional position. So that's our test account. And just to show an example of how to use it, I'm going to run it here. So you can see, like, okay, if I start with a humble balance of $50, then you can see here that the record balance is 50. And then, for example, if we now see this here, see we've got no positions, we've got no trades. So now what we want to do is to create an abstract class or interface for an exchange. So this is what we're going to do now. So model, I'm going to do this. Model an exchange. And I'll just copy and paste the code. The key important difference here is that we are extending a count. So because, for example, in some parts of a code, we don't want to expose the ability to create an order, either a market order or a limit order. We just want to say, okay, you can access only the balance. So it's just a bit more dangerous if, for example, if we pass the exchange, because we don't want the strategy to actually execute any orders. We just want it to generate some like orders, so then the next layer can then run the orders. So it's just a good practice, really. So, and then this is the exchange, and then there's just obviously there's a few more. For example, you would want to be able to have the ability to send multiple orders at once. But just for simplicity, then I've just kept it to singular orders. But in reality, you have the ability to send multiple orders and all different sorts of order types. And now we're going to create like a mock test exchange. I'm just going to copy and paste the code here. And then maybe just go over it. So here's another key important detail as well. So this is like a design pattern called composition over inheritance. So rather than extend the test account, it's now composed. So rather than using inheritance, I'm just using composition instead. So I pass in the account, and then I just, for example, here for balance, I just delegate it to balance. The key functionality here is the market order. So we're not going to go over limit orders because we don't have any level 3 order book data, and it will just increase the complexity of this tutorial. So the key important thing here is just like we're just mocking like how an exchange creates and closes positions and balance. And so it just updates the position based on the trade. And if it's to reduce our position, then there's an associated profit and loss, and then we use that to add to the balance, and then we just append it to the trades. But yeah, that's the main. And then if it's we won't go into more. If you're interested, you can look into this more further. But this is just a very simplified version of it. And I just want to show now like how to create positions in the test account, like the difference, because you may not know what the difference between like a trade and a position, and it will be really clear if we show an example. So this is what we're going to do now. And we're going to do test exchange, and then we're going to pass in test account, decimal, 50, decimal, 10, quantity, decimal, 5.0, exchange, and then we're going to call Bitcoin, decimal price. Okay, so we're going to pass a market order with a price and known quantity. So obviously when we send it like in the real world, we would not say like create a market order with a specific price, but that could just be so we're just using this purely just for testing purposes, really, but I think I should make this none, but this is just to give an example, because that's the last known traded. Let's say that's the last known traded price, but that's what you would expect the price to trade, but it doesn't always, because the price could change, right? And that's what's called like slippage. But yeah, anyway, this is just like so now we've run the trade, and you can see that it's a positive. You see the sign quantity, it's a positive number, and so that means that it's gone long, and that's the price it traded at. It could have deviated, right? So it could have, like, the price could have moved, and it could have like been 9 or 11, and because it's opening a position, there's no associated P&L because it's not reducing or closing the position. So that's that. And now I want to just show the exchange now. So the exchange, the balance is still 50, but see here, it's now got a position, and that's the position. So it's a long position. The price is at 10, and then that's the trade it's at. And I just want to show now, like, for example, closing this position, because our strategy, what it does is at the beginning of a time interval, it opens a position, and then after 12 hours, at the end of the time interval, we close the position and open up a new position. So I just want to explicitly do this manually, but automatically we want the ability to do this. So so now we're going to close it. Maybe if I just make it clear as well. So we're going to close the position. And did I say this open position? Okay, so let me just make this clear that this was opening position. Okay. So what we're going to do is we're going to close it down altogether. So let's say the price has shot up from 10 to 15. And so we want to take the negate the quantity, right? So flip it to turn around, so from +5 to -5, and that will close the position. We'll see this. So now we're going to run it. So you can see that the signed quantity is -5 because we're now going short by 5. And that's the price it traded at. And you can see now, because it's reducing, or in our case, actually closing the position in full, there's an associated P&L with it. So it's made $25. And now, if we look at the exchange, we should see that, let's have a look at the exchange. So you see here that the position is now empty. And now we've got 2 trades. One was to open and the other one was to close. So imagine like we're at the end of the time interval and we close the position, but at the same time we also want to open a position. So ideally we open, and then the next trade straight afterwards is to open a new position. And I also just want to show how it was calculated, the profit. So for example, we have the entry notional value, which is essentially the number of units we bought at the price, and that's 50, right? Because we had our account had did we say this? Yeah, $50. So that's the entry size or notional value. And now if we look at maybe if I just copy this in. Now if we look at the exit notional value, that's the price that our trade closed at. So then you just take the delta of that, and then you can see that this is how this is the maths of how it calculated it. So that's 25. But you wouldn't need to do this. Is just for testing and educational purposes. If we were like connecting an exchange, they would have like a test environment where you can actually code this and get the position, so you don't need to manually manage the positions yourselves. There may be some cases where you want to manually manage and make sure it's in sync with the actual market's state, but for our purposes, yeah, we're just going to, this is just like a mock exchange. And so a really important decision, like in terms of building the system, is like our API design. And we're going to now start building the strategy API. We want to design the strategy API in such a way that it makes it super quick and easy to build a new interface. We don't have to copy and paste lots of code. We just need to extend like a base class, and it takes care of all the nuances of connecting to an exchange and sending orders. And so that's what our class is going to do. And we're just going to keep a very basic, and we can build upon this. So our strategy, notice it hasn't extended tick, because we also, on the tick, we also, because we're going to use compounding trade sizing, that we need to know what the balance is. And we don't want I don't want every class to pass in an account, because it may not need it. So it's just, it's like our tick class, but it's just got an additional account parameter. And so the return type is an optional, so it's either going to be null, or it's going to be a list of orders. And the orders, it's either going to be just an order to open, to open a position, but it could also be a list of like two. It could be one to close the existing position, and then another order to open a new position. But we'll show it in detail later. So now what we want to do is to actually implement our strategy now. Put this mark down. And so essentially what we're going to do is to extend our class. Oops, I'm going to put this back into Python. There we go. So rather than, I'll go over all the code. So in the construction, we're passing in the symbol, we're passing in the model, and the model, if we can have a look here, you can see the base class for all your neural network modules, but we're just using a linear model, right? And then we want to need to stream, we're going to get like a stream of prices coming and like in 12-hour intervals for us, because it's we're predicting 12 hours ahead always. So each 12-hour interval we're going to get a new price, and we want to stream this into our log return lags. And this is the scale factor. So for example, this at the moment we're just going to treat it as a constant, but this could be dynamically adapting. And this is essentially if we're going to use leverage, but it could also be the opposite. So it could say like, we don't use all our capital, we only use like 10% of our capital, dependent on on how much our risk tolerance is. So that's as you can see here. And then if it's an optional, so if it's optional, then it's just going to say that the scale factor is 1.0. So it's going to use all the capital that's available in the balance. And so maybe if I go to onTick, that'd be so when it gets a new price, as in there's a new time interval, it's 12 hours have passed and there's a new price, then it's going to pass it into log returns lag. We've seen how this works. So this is the features for our model, which we denote as x. And if x is not empty, then we pass into the model. That's our prediction, right? And this is this is the model, and this creates the order. So it passes in our prediction and the account and the price it traded, like essentially mocking the trading price, and that's the orders it generates. And just a really key important detail maybe is here. So this is where it creates the order. So if there's already an existing position, then it returns two orders, one to close the position and another order to open a new position. But if it's running for the first time, Oh, they're also not first time. But if there isn't an open position, then it's just a singular order, just to open an order to have an open position. And yeah, then this is the signed compound trade size. But if you're interested, then you can study this code. So that's the strategy, right? And I just want to show you like how the strategy streams prices in and to generate orders. So let's this is all the components of our strategy that we pass in, right? And on the first, let's say this is the first 12-hour interval, we pass in, we call on tick, and we pass in, let's just say this is not an authentic price of a genuine price of Bitcoin dollar, but just say for arbitrary it's $10, right? So it doesn't generate any orders because it hasn't filled up enough data in our window. But in production, you would not do this because you couldn't wait like for like over a day and a half to get the latest like lags. So in a real production system, you would get the prices and already populate it before it actually starts to trade, right? So it doesn't have to wait. Because imagine like if it was like the forecast horizon was like a week instead of hours, like 12 hours, it was a week, right? So then you would have to wait 3 weeks for your model to start trading, so that it doesn't make sense. So anyway, we now, and on the second time interval, but I'm going to keep it like this just to show you like what's happening, right? So again, on the second tick, we don't have enough data to generate orders, and so let's just say that was like today at midnight, and then that's the next time interval. And now we're going to look at the third time interval. And again, there's not enough to generate orders. And now if we look at the fourth orders, sorry, the fourth 12-hour interval, right? That if we run this now, that's now it's generated an order. So essentially our order, it's created an order, and it's basically essentially it's predicted that it's going long, because remember this is a signed quantity. If it's negative, that means it's telling us to open a short position. But here it's saying like this is the price, and our account is $100, right? So that's why the quantity is 1, because that's how much we can buy with our available capital. Now that's the order, right? And now we need, like, our system needs to be able, so we're going to do this manually, right, and explicitly, but we would automate this. But I just wanted to understand what's happening. So now we've got orders. Now we actually want to execute orders. And this is where we can use our Exchange API. So now what we're going to do is going to create an instance of Exchange, which we're going to call test exchange account order. Oops. And then call market order, and we're going to pass in all the parameters here, right? So order.sim, order.signed quantity, and then the price. And what we're going to do here we can pass it as a decimal as well, but yeah. So now we're going to run this. So you see here that it's created a trade now. And now if we look at the exchange to see what's happened. So you see here it's created the position now, and it's bought 1 unit, and you can see we've got a trade here, and the associated P&L is 0 because it hasn't closed or reduced the position. So now this is what we're going to do now is we're going to do this. We're now going to, so let's say we've now on the next 12-hour interval, and now we've got a new price. So we want to stream that new price into our strategy. And so now we stream it in and see now what happens. It's generated 2 orders. The first order is saying to close the position because our position at the moment is +1, right? And we want to close it, so we need to send an order for -1, and that's going to close the position. And once it's closed the position, we want this other one's going to open up a new position, and you can see here that it's a negative number, so it's now going to open a short position, and that's essentially a short position is you're making a bet the price is going to go down. And I just want to show you like manually what happens. So for example, oops. So now what we're going to do is we're just going to do this. We're going to, so that's the first order, remember, was to close. So it's this one. We're going to run this and then to see what happens. So we've now run it, and you can see now we've got an associated profit and loss of $15. And now if we look at the exchange, you can see now positions now closed. We have no positions available. And you can see, for example, we could write this down into a CSV file to analyze what trades were done. And so, but that's just one order of 2. And now the next order, so we're just now going to call, actually maybe just easier. So now we're going to call the exchange again, and so this time it's going to call market order. Now we can just use this. Okay. So now it should open a position. And you can see here it's a negative number. So this represents a short position. And you can see all our trades are accumulating. But this is just a test. So we can just accumulate the trades for now. But it would probably be better if we wrote all that rather than keep them in memory, is to write them down to disk like as a CSV file. And so yeah, so that's, and now what we're going to do is just to show, for example, now if we, let's say the price goes down, and it's again just to show what happens. So now it's going to do the opposite, right? So that was, it's going to give us the size so we can close the position in full, and then it's going to open a new position, which is it's now going to be a long position, and it's going to do exactly the same. So we would do, for example, orders exchange. So you see here that we've now the position is going to be closed. Oh, and we've got the associated P&L as well. So you see the position is closed, and then for the second order, we're going to they'll open up a new position that'll be long. So maybe if we just do that now as well. if I run exchange. So you now see that we have a long position of this size. And that concludes the basics of the trading system. There's a lot more, but I decided to cut a lot out to make the video shorter. And so to conclude, I've shown like how to put it all together, shown how to stream prices to create the features, and show how the model makes a forecast, how it all fits together. So showing like how the strategy generates orders that opens and closes positions. So, and then I think what we'll do for the next video, we're going to maybe get rid of this. For the next video, we're going to put it live. I'm still hesitant to actually give the code to actually like send orders to a real exchange, because I'm just worried that, for example, someone downloads the code, changes some of the parameters, maybe the weights or even what it's actually trading, puts a lot of money, loses it, and then like yeah, I just want to avoid situations like that. So I think I'll pretty want to make it transparent, but so what I'll do is I'll probably give all the code, but just not the actual implementation of the exchange. Then what we'll do is we'll put it live with some real money and let it run. And then, for example, if it starts to we can still learn, for example, if the performance starts to decay, because this is a very important lesson. This will be called like model drift, but we'll only find out until we actually run it live. And then, for example, if there is like model drift, then there's something like you can do like a sliding window approach to training. So rather than just like a traditional time split, then we can just do like a sliding window, and then just always recalibrate our weights after a certain time. Anyway, but I will maybe run this for like a month or 2 months, run it and then document it and then create another video. So you won't see it next week or anything, but yeah, we'll see it lately in the future. So I think that concludes everything. That's feel free to ask any questions. I like to answer the questions. And yeah, please like and subscribe, and thank you very much.